Hey, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the Corbettmaths practice questions on inequalities. If you need any extra help on inequalities, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video numbers 176, 177, 178 and 179, there's dedicated video tutorials there on various aspects of inequalities. Alternatively, you can scan the QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we've been asked to match each inequality to the correct description. So we've got four inequalities here and four descriptions. So the first one, it says x is greater than 4. So x is greater than 4 would be the top one. The next one, x is less than or equal to 4. So x is less than or equal to 4. So that's the top one there. X is less than 4. So that's that one there. And then finally, x is greater than or equal to 4 would be the bottom one there. Okay, let's look at our next question, question number 2. So question number 2, we've been asked to represent the inequality x is greater than 2 on this number line. So x is greater than 2, we're going to put a hollow circle at 2 because it's greater than, so we're not going to shade it in. If it was greater than or equal to 2, you'd shade it in. If it was less than, you'd do a hollow circle. If it's less than or equal to, you would shade it in. Because it's not equal to, you're just going to do a hollow circle. And then we want to point an arrow to the direction of the values of x that would represent this inequality. So x is greater than 2, so we're going to put an arrow to the right because all the values of x greater than 2 would represent that inequality, such as 3, 4, 5 and so on. So this represents x is greater than 2. Okay, let's look at our next question, question number 3. So question number 3, we've been asked to represent the inequality x is less than or equal to 4 on this number line. Because this is less than or equal to 4, we're going to do a shaded in circle at 4. And it's less than or equal to, so we're going to put an arrow to the left because it's less than or equal to 4. And that's it. So that would represent x is less than or equal to 4 on that number line. Okay, let's look at our next question, question number 4. So question number 4, we've been told that y is greater than or equal to 2, and we've been asked to circle the correct inequality. Okay, so we're looking for y is greater than or equal to 2. So this is y is greater than 2, so it's not that one. This is y is greater than or equal to 2, so it is that one. This is y is less than or equal to 2, so it's not that one. And this is y is less than 2, so it's not that one. So that's it. Okay, our next question, question number 5. Okay, question number 5, we've been asked to solve the inequality 3x is less than 24. So whenever you want to solve an inequality like this, you just solve it like you would solve an equation. So here you got 3 times x is less than 24. We just want to get x on its own on the left hand side here, so we don't want this multiplied by 3. So let's divide both sides of the inequality by 3. So we're going to divide by 3 and divide by 3. So on the left hand side, we're dividing by 3 to get rid of the multiply by 3. So we're just going to be left with x. And then we've got less than, and then 24 divided by 3 is 8. So if 3x is less than 24, x is less than 8, and that's it. So x is less than 8. So you solve inequalities like this in the same way that you solve an equation. Okay, let's look at our next question, question number 6. So question number 6, we've been asked to solve the inequality 3x subtract 8 is greater than 16. So we want to solve this inequality, so we want to get the x on its own. So if we wanted to solve this like we would solve an equation, we would want to get rid of this minus 8 to begin with. So let's add 8 and add 8. So on the left hand side, we've got 3x minus 8. We're adding 8 to get rid of the minus 8. So we're just going to be left with 3x. And then on the right hand side of the inequality, we had 16. We're adding 8, so it's going to be 24. We've now got that 3x is greater than 24. We don't want this multiplied by 3 here, so let's divide by 3 and divide by 3. 3x divided by 3 would just be x, and then on the right hand side we have 24 divided by 3, that would be 8. So x is greater than 8, and that's it. Okay, let's look at our next question, question number 7. So question number 7, we've got this inequality represented on the number line, and we've been asked to circle the correct inequality. Okay, so if we have a look at this, we've got the values of x that are between minus 3 and 1, but they're also shaded in, so it means that x is going to be greater than or equal to minus 3, but less than or equal to 1. So that means it's going to be this one here. The x is greater than or equal to minus 3, but less than or equal to 1. It wouldn't be this one because this one would have hollow circles. It wouldn't be this one because this one, the first one would be shaded, but the second one would be hollow. And it wouldn't be this one because for this one, the first one would be hollow and the second one would be shaded in. But for this one, both of them would be shaded in. Okay, let's look at our next question, question number 8. So question number 8 part A says solve the inequality 2x minus 1 is less than 9. So we want to solve this in the same way we would solve an equation. So we want to get the x on its own. So let's get rid of this minus 1 to begin with by adding 1 to both sides of the inequality. So we're adding 1 to get rid of the minus 1 on the left hand side. So we're just going to be left with 2x. And on the right hand side we've got our less than, and then 9 plus 1 is equal to 10. So we've got that 2x is less than 10. Now we want the x on its own, so we don't want this multiplied by 2, so let's divide by 2 and divide by 2. We're dividing by 2 to get rid of this multiplied by 2, so we're just going to be left with x. And on the right hand side of the inequality, 10 divided by 2 is equal to 5. So x is less than 5. And that's it. Okay, carrying on. So we've got this diagram and we've got this inequality represented on the number line, and we've been asked to write down the inequality represented on the number line. So as you can see, we've got this hollow circle at -2 and the arrow is pointing to the right. So that means that we're looking at the values of x that are greater than -2. So x is greater than -2, and that's it. Okay, let's look at our next part, part C. So part C says write down all the integers. So integers, there'll be numbers such as 0, 5, 7, -4 and so on, that satisfy both inequalities shown in part A and B. So if we have a look at A we had x is less, so A was x is less than 5, and B, x is greater than -2. So we want to find the integers that would satisfy those. So we want to find the values of x that would satisfy both of these inequalities, but also be integers. So x is greater than -2. So we can't have -2 because it's greater than -2. So greater than -2, so going upwards would be -1. Then we would have 0. Then we would have 1. Then we would have 2. Then we would have 3. Then we would have 4, but we can't have 5 because x is less than 5. So that's it. So they're the integers that would satisfy both of those inequalities in part A and part B. Okay, let's look at our next question, question number 9. So question number 9, we've been asked to circle the list of integers that satisfies the inequality n is greater than or equal to 4 but less than 8. So greater than or equal to 4. So I'm just actually going to write down the integers to satisfy this. So greater than or equal to 4, so that'd be 4, 5, 6, 7, but it says less than 8, so that's it. So it's going to be this option here, and that's it. Okay, let's look at our next question, question number 10. So question number 10, part A, we're told that n is an integer, and we've got the inequality n is greater than -2, but less than or equal to 3. And we've been asked to list the possible values for n. So it's greater than -2, so it can't be -2. So going upwards, we've got -1, and then 0, and then 1, 2, and it says less than or equal to 3, so 3 as well. So that's it. So they're the integers that would satisfy that inequality. Okay, and then part B. Part B, we've got this number line, and we've been asked to write down the inequality shown in the diagram. So we've got a shaded in circle at 1, and then we've got an arrow pointing to the values of x that are bigger than 1. So it's going to be x is bigger than or equal to 1, and that's it. Okay, and then part C. Part C, we've been asked to solve 3y subtract 4 is greater than 17. So we want to solve this inequality, so let's add 4 to both sides. So add 4 to the left hand side and add 4 to the right hand side. On the left hand side, we're adding 4 to get rid of the -4, so we're just going to be left with 3y, and then we've got the greater than symbol, and then 17 plus 4 is 21. And now we don't want this multiplied by 3, we just want to get the y on its own, so let's divide by 3 and divide by 3. 3y divided by 3 is just y, and then the greater than symbol, and then 21 divided by 3 is 7. So that means that y is greater than 7, and that's it. Okay, let's look at our next question, question number 11. So question number 11, we've been asked to write down one integer that satisfies the inequality 6x is greater than 42. Now I'm laughing because it says one integer, so we could choose any. We could use a million. 6 times a million is greater than 42. We could write down 75. 6 times 75 is greater than 42, and so on. So I'm just going to pick one. I'm going to choose 10. So 6 times 10 is equal to 60, and that's greater than 42. You'd have to choose an integer that's greater than 7, though, because 6 times 7 is 42, and 42 is not greater than 42. So you'd have to choose 8, 9, 10, and so on. And that's it. Okay, let's look at our next question, question number 12. Okay, let's have a look at our next question, question number 12. So question number 12a says solve 3x plus 4 is less than or equal to 13. Okay, so we want to solve this inequality. So let's take 4 away from both sides of the inequality. So on the left hand side, we're taking away 4 to get rid of the plus 4. So we're just going to be left with 3x. And then we'll have less than or equal to. And 13 take away 4 is 9. Okay, now we want to get rid of this multiplied by 3, so let's divide by 3 and divide by 3. So on the left hand side, we'd just be left with x, and then that's less than or equal to, and 9 divided by 3 is 3. So x is less than or equal to 3, and that's it. Okay, let's look at our next part, part B. So part B says write down all the integer values of x that satisfy -2 is less than or equal to 2x, which is less than 6. Okay, so let's have a look at this inequality. Now, interestingly, we've got here 2x. We want to find all the integer values of x, so let's divide through by 2. So let's divide everything by 2 here. So -2 divided by 2 is -1, and it's going to be less than or equal to. and 2x divided by 2 would just be x, and then that would be less than, and 6 divided by 2 is equal to 3. So we've got the x is greater than or equal to -1, but less than 3. So it's greater than or equal to -1. So -1, 0, 1, 2, but it's less than 3, so that's it. So they're all the integer values of x that satisfy that inequality. Okay, let's look at our next question, question number 13. So question number 13 is a calculator question, and if you want to use a calculator, you can if you want to. I'm going to do it without one because actually you can as well. So here you got 5x plus 2 is less than 6. So we want to solve this inequality, so let's get rid of the plus 2. So let's take 2 away from both sides. So on the left hand side of the inequality, 5x plus 2, we're taking away 2 to get rid of the plus 2, so we'll just be left with 5x, and that's going to be less than, and 6 take away 2 is 4. So we've got the 5x is less than 4. Now we want to get rid of this multiplied by 5, so let's divide by 5 and divide by 5. So on the left hand side, 5x divided by 5 would just be x, and then we've got that's less than, and 4 divided by 5 is 0.8 or 4/5. You can write it either way. And that's it. So that's our answer. X is less than 0.8, or you could write x is less than 4/5. It's up to you. Either one of those would be totally fine. And that's it. Okay, question number 14. So question number 14, we've been asked to write down all the integer values of x that satisfy this inequality. So here if we have a look at it, we've got 4x is greater than 9, but less than or equal to 28. Now we want to find the integer values of x, so we don't want 4x, we just want x. So let's divide everything by 4. So let's divide by 4, and divide by 4. So 9 divided by 4, it's a calculator question, so 9 divided by 4 would be 2.25 or 9/4, but I'd probably write it as a decimal, 2.25. It actually helps us spot the integer values. That's going to be less than, 4x divided by 4 would just be x, that's x, and that'll be less than or equal to, and 28 divided by 4 is 7. So you've got the x is greater than or equal to 2.25, but less than or equal to 7. Now remember, x can take integer values, so that's going to be greater than 2.25, so that's going to be 3, 4, 5, 6, and 7. And that's it. They would be the integer values of x that would satisfy that. And that's it. Okay, let's look at our next question, question number 15. So question number 15a says solve the inequality 4x plus 6 is greater than or equal to 2. So we want to solve this, so let's get rid of the plus 6, so let's take away 6 from both sides of the inequality, so take away 6 and take away 6. Okay, so on the left hand side, 4x plus 6, we're taking away 6 to get rid of the plus 6, so we're just going to be left with 4x, and that's going to be greater than or equal to, and 2 take away 6 would be minus 4. Okay, now that's 4 times x, we don't want this times by 4, so let's divide by 4 and divide by 4. So on the left hand side, 4x divided by 4 would just be x, and that would be greater than or equal to, and negative 4 divided by 4 would be negative 1. So x is greater than or equal to negative 1, and that's it. Okay, and then part B. Part B says write down the inequality shown by the diagram. So here we've got a hollow circle at 3, so it's going to be less than or greater than. It's not going to be less than or equal to or bigger than or equal to. And here if we have a look at the arrow, it's pointing to the left, so it's pointing to all the values of x that are less than 3, so x is less than 3, and that's it. Okay, then if we have a look at part C, part C says write down all the integers that satisfy both inequalities shown in part A and part B. So part B we've got x is less than 3, and in part A we had that x is greater than or equal to negative 1. Just going to have to check that, yep. So we want to find the values of x that are greater than or equal to negative 1, but less than 3. And remember that we're looking for integers, so bigger than or equal to negative 1, so negative 1, 0, 1, 2, but not 3 because it's less than 3. And that's it. So they're all the integers that satisfy both inequalities. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 16. So question number 16a says solve 4n is less than 9, subtract 2n. Okay, so we want to solve this inequality. Now notice that we've got n's on both sides of the inequality. So let's get rid of the lowest number of n's, this minus 2n. So let's add 2n to both sides. So 4n plus 2n is 6n, which is going to be less than, and then we've got 9, and we added 2n to get rid of the minus 2n, so we've just got that 9 there. So we've now got that 6n is less than 9. We don't want this multiplied by 6, so let's divide both sides of the inequality by 6. So 6n divided by 6 is n, and then that's less than, and 9 divided by 6, and it's a calculator question, so that's 1.5. So n is less than 1.5, and that's it. Okay, and then part B, it says on the number line, show the set of values of x for which 1 is less than x plus 2, which is less than 5. So here we want to have our x in the middle on its own, so we don't want this plus 2, so let's take away 2 from everything here in this inequality. So 1 take away 2 is negative 1, which is going to be less than, and x plus 2, we've taken away 2 here, so that's just going to be x, and then that's going to be less than, and 5 take away 2 is 3. So we've got that x is greater than negative 1, but less than 3. So let's put hollow circles at negative 1 and 3, and let's join them up. And that's it. So x is greater than negative 1, but less than 3. And we haven't shaded them in, they're hollow circles, because we've got x is greater than negative 1 and less than 3. Okay, let's have a look at our next question, question number 17. So question number 17a says, solve the inequality 5x subtract 2 is less than 22. So we want to get the x on its own, so let's add 2 to both sides of the inequality. So on the left hand side, we're adding 2 to get rid of the take away 2, so we're just going to be left with 5x, and that's going to be less than, and 22 plus 2 is equal to 24. So we've now got the 5x is less than 24. We don't want this times by 5 here, so let's divide by 5 and divide by 5. 5x divided by 5 is just x, and that's going to be less than. And 24 divided by 5, it's a calculator question, so we can just do 24 divided by 5, and that's equal to 24 fifths, or 4.8. So I'm going to just write x is less than 4.8, and that's it. You could write it as a fraction if you wanted to. Okay, and then part B. Part B says, given also that x is greater than 1 and x is an integer, write down all the possible values of x. So x is greater than 1, but it's less than 4.8, and it's an integer. So let's consider integers. So greater than 1, so that'll be 2, and then 3, and then 4, but not 5 because x is less than 4.8. So that's it, 2, 3, and 4. Okay, let's have a look at our next question, question number 18. So question number 18 says, solve the inequality 2 brackets 3x subtract 5 close brackets is greater than or equal to 43. So my first step here is I'm going to expand the brackets. So I'm going to multiply what's in the brackets by 2. So 2 times 3x is 6x, and then we take away, and 2 times 5 is 10. And that's greater than or equal to 43. Okay, now we want to get the x on its own, so let's get rid of this minus 10. So let's add 10 and add 10 to both sides of the inequality. So on the left hand side, we're adding 10 to get rid of the minus 10. So we're just going to be left with 6x, and that's greater than or equal to 53. And now we want to find out what x is, so let's divide both sides by 6. So divide by 6 and divide by 6. So on the left hand side, we're just going to be left with x, and that's greater than or equal to. And then we're going to do 53 divided by 6. So 53 divided by 6 is equal to 8.8333, and so on. Or you could write it as a fraction. You could write it as x is greater than or equal to 53 over 6. And that's it. You can write the answer either way. You could write it as a decimal, x is greater than or equal to 8.83 recurring, or x is greater than or equal to 53 sixths. Okay, let's look at our next question, question number 19. So question number 19, we've been asked to solve the inequality 2x plus 9 is greater than 19 subtract 8x. Okay, so here what we want to do is we want to bring all the x's to one side and all the numbers to the other side. So let's get rid of the lowest number of x's, and the lowest number of x's would be the minus 8x, because 2x minus 8x is the lowest one. So let's add 8x to both sides of the inequality. So if we add 8x to the left hand side, we're going to have 10x plus 9 is greater than, and then we're going to have 19. Okay, now we've got 10x plus 9 is greater than 19. Let's get rid of this plus 9, so let's take away 9 and take away 9. So then we're left with 10x is greater than, and then we've got 19, take away 9, that's going to be 10. So we've got 10x is greater than 10, let's divide by 10 and divide by 10, and then we're just going to get that x is greater than 1, and that's it, x is greater than 1. Okay, let's look at our next question, question number 20. Okay, so question number 20, part A says, solve the inequality 3 bracket x minus 4, close brackets, is less than or equal to 15. So what I'm going to do is I'm going to expand the brackets. Now you could divide both sides of the inequality by 3 if you wanted to. Actually, that'd be quite a good step, but I'm actually just going to expand the brackets because that's what I said I was going to do. 3 times x is 3x, and then 3 times minus 4 would be minus 12, and that's going to be less than or equal to 15. Okay, now we want to get the x on its own, so let's get rid of this minus 12. So let's add 12 and add 12 to both sides of the inequality. So on the left hand side, we have 3x minus 12. We're adding 12 to get rid of the minus 12, so we're just going to be left with 3x. And that's going to be less than or equal to, and 15 plus 12 is 27. Okay, we're nearly there. We just need to divide by 3 and divide by 3. 3x divided by 3 would be x, and that's going to be less than or equal to 9. So x is less than or equal to 9, and that's it. Okay, then part B. Part B says, write down the inequality shown in the diagram. So let's write down the inequality as shown in this diagram. So x is going to be bigger than or equal to negative 1. So bigger than or equal to negative 1, but less than 4. Less than 4. And that's it. X is bigger than or equal to negative 1, but less than 4. Okay, let's look at our next question. So question number 21a says solve the inequality 3x plus 7 is less than 20. Okay, so we want to solve this inequality, so let's get rid of the plus 7. So let's take away 7 from both sides of the inequality. So on the left hand side, we're taking away 7 to get rid of the plus 7, so we'll be left with 3x. And 20 take away 7 is 13. Okay, so we've now got that 3x is less than 13. We want to get rid of this multiplied by 3, so let's divide by 3 and divide by 3. So on the left hand side of the inequality, 3x divided by 3 is just x, and then 13 divided by 3 would be 4.333 and so on. Or you could write it as a fraction, you could write x is less than 13 over 3, and that's it. And I'm going to write it as a fraction, 13 thirds, and that's it. Okay, then let's have a look at part B. Part B says write down the integer value of x that satisfies 16 is less than or equal to 3x, which is less than 20. Now, because it's integer value, it seems to imply that there's only one. So let's have a look and see if there's just one value of x that would work here, one integer value of x that would work here. So we don't want the 3 here, we just want x. So we don't want this multiplied by 3. So let's divide everything in the inequality by 3. 16 divided by 3 would be 5.333 and so on. That's going to be less than or equal to 3x divided by 3 is just x, and then 20 divided by 3 would be 6.666 and so on. So you get the x is bigger than or equal to 5.33333 and so on, but less than 6.66666 and so on. So in terms of integers, it's going to be bigger than or equal to 5 1/3, so it's going to be 6, and there's only one value because that's less than 6.666 and so on. So 6, and that's it. Okay, let's look at our next question, question number 22. So question number 22, we've been asked to solve the inequality 9x plus 4 is less than 5x subtract 14. Okay, so we've got x's on both sides of this inequality, so let's get rid of the lowest number of x's, which is the 5x. So let's take away 5x's and take away 5x's. So on the left hand side, we had 9x plus 4, we're taking away 5x's, so we're just going to be left with 4x's. So 4x plus 4 is going to be less than, and we're taking away 5x to get rid of the 5x, so we're just going to be left with minus 14. Okay, so we've now got the 4x plus 4 is less than minus 14. We don't want this plus 4 here, so let's take away 4 and take away 4. So on the left hand side, we'll be left with 4x, and that's going to be less than, and minus 14, take away 4 will be minus 18. Okay, we're almost there. We now want to get rid of this times by 4, so let's divide by 4 and divide by 4. So 4x's divided by 4 would just be 1x, so that's x, and then that's less than, and we're going to do minus 18 divided by 4. It's a non-calculator question, so let's half it and half it again. So half of minus 18 is minus 9, and half of that would be minus 4.5. So x is less than minus 4.5, and that's it. Okay, then let's have a look at our next part. So our next part says that y is an integer, so numbers such as 7 or minus 4, 0, or so on. And we're then told to write down all the solutions of the inequality. Negative 8 is less than or equal to 2y, which is less than 0. So this is 2y, so let's divide everything by 2. So let's divide by 2, divide by 2, and divide by 2. So minus 8 divided by 2 would be minus 4, and that's less than or equal to. And 2y divided by 2 would be y, and then that would be less than. And 0 divided by 2 is 0. So y, the integer, is bigger than or equal to negative 4. So it could be negative 4, it could be negative 3, it could be negative 2, it could be negative 1. It's got to be less than 0, so that's it. They're all the solutions to that inequality. Okay, let's look at our next question. So question number 23, we're told that n is an integer and it's bigger than or equal to negative 4 but less than 1. And we've been asked to write down all the possible values of n. So it's an integer, so it's bigger than or equal to negative 4, so negative 4, negative 3, negative 2, negative 1, 0, but not 1 because it's less than 1. So that's it, there are all the possible values of n. Okay, and then part B. Part B, we've been asked to solve this inequality. 4x plus 11 is less than 27. So let's take away 11 from both sides of the inequality. So on the left-hand side, we'll be left with 4x. And on the right-hand side, we've got 27. Take away 11, that'll be 16. And then we just need to divide by 4 and divide by 4. And 4x divided by 4 is just x, and that's going to be less than. 16 divided by 4 is 4. So x is less than 4, and that's it. So question number 24 says Lee is y years old. So Lee is y years old. We don't know how old that is. We just know it's y years old. And Toby is 8 years younger than Lee. So actually, if Lee is y and Toby's 8 years younger, that would be y subtract 8 because it's 8 years younger. Because whatever age Lee is, such as 20, Toby would be 12. So you do 20 take away 8 and so on. And then we're told the sum of their ages is less than 41. So the sum of their ages, when we add their ages together, it's going to be less than 41. And part A says, write down in terms of y an inequality to show this information. Okay, so we need to write down an inequality. So Lee is y years old, and Toby's 8 years younger, so that's y take away 8. and the sum of their ages. So let's add together their ages. So y plus, and then y minus 8, and that's going to be less than 41, so that's less than 41. Okay, so let's add them together. Y plus y is 2y, and then we've got minus 8, because obviously if you do y minus 8, you add another y on, you'd have 2y minus 8, and it's going to be less than 41. So it says write down in terms of y, an inequality showed this information, so it's going to be 2y minus 8 is less than 41. The sum of their ages, which is 2y minus 8, is less than 41. And then part B. Part B says work out the oldest age that Lee can be, and to give our answer as a whole number in years. So remember that Lee is y years old, so Lee is y. So let's solve this inequality, and then we'll be able to find the oldest age he could be. So let's solve this. So if we want to solve this inequality, let's get rid of the minus 8. So let's add 8 to both sides of the inequality. So on the left hand side we'll be left with 2y, and that's going to be less than, and 41 plus 8 is 49. Okay, now we've got 2y is less than 49. We don't want this times by 2, so let's divide by 2 and divide by 2. 2y divided by 2 is just y. That's going to be less than, and 49 divided by 2 is 24.5. Half of 49 is 24.5. So Lee's age, which is y, is going to be less than or equal to 24.5 years old. So if he's less than 24.5 years old, the oldest age he could be would be 24. And that's it. Okay, let's look at our next question. So question number 25. So question number 25, we're told that x is an integer, so it's an integer. We've been asked to write down all the solutions of the inequality. 3 is less than 2x plus 1, which is less than 13. So what we're going to do is we want to get x in the middle here on its own. So let's take away 1 from everything. So if we take away 1 from everything, what would we get? Well, 3 take away 1 is 2. 2x plus 1 take away 1 would be 2x. And 13 take away 1 would be 12. So we're just taking away 1 from everything. Now we're going to divide everything by 2 because we don't want this times by 2 here. So let's divide by 2, divide by 2, and divide by 2. So 2 divided by 2 is 1. And then 2x divided by 2 would be x. And then 12 divided by 2 would be 6. So we know that x, this integer, is bigger than 1, but less than 6. That's going to be 2, 3, 4, or 5. And they're all the integers that would satisfy that. Okay, let's look at our next question, question number 26. So question number 26 says, Lorcan has been asked to solve the inequality 4x subtract 2 is greater than or equal to 9x plus 8. And his solution is shown on the number line. And we've got the solution. And I'm just going to write down what the solution is. We've got x is, because it's pointing to the right, x is bigger than or equal to, because it's shaded in circle, bigger than or equal to, because it's bigger than or equal to, it's shaded in as pointing to the numbers to the right, bigger than or equal to, negative 2. And then we're asked, is Lorcan's solution correct? Explain your answer. Okay, so let's solve this inequality and see what the answer should be. So we've got 4x minus 2 is greater than or equal to 9x plus 8. Okay, so we want to solve this inequality. So whenever I'm solving an inequality like this, I like to get rid of the lowest number of x's. So we've got 4x's and 9x's. The lowest number is 4x's, so let's take away 4x's from both sides of the inequality. So on the left-hand side, we're taking away 4x's, so we're going to be left with minus 2. And that's going to be bigger than or equal to. And then 9x plus 8, take away 4x's, would be 5x's plus 8. So we've just taken away 4x's from both sides of that inequality. Okay, now we want to get the x on its own on the right-hand side here. So let's get rid of the plus 8. So let's take away 8 and take away 8. Minus 2, take away 8 would be minus 10. And that's going to be bigger than or equal to. And then we've got 5x plus 8. We're taking away the 8 to get rid of the plus 8, so we're just going to be left with 5x. Okay, we're almost there. Now we don't want to have this times 5 here, so let's divide by 5 and divide by 5. And minus 10 divided by 5 would be minus 2. And that's going to be bigger than or equal to. And 5x divided by 5 would just be x. So here we've got that negative 2 is bigger than or equal to x. Now we tend to have our x first. So what we want to do is we want to turn this inequality around. And whenever we're turning the inequality around, we also need to turn the inequality sign around, because if you notice here, we've got that negative 2 is bigger than x. So that means that negative 2 is bigger than whatever x is. So we can't just swap the minus 2 and the x around, and then suddenly we'd have that x is bigger than or equal to negative 2, and that's not the case, because it says that negative 2 is bigger than or equal to x. So if we're turning the inequality around, we need to turn the equality sign around as well. So we're going to have the x, and instead of bigger than or equal to, we're now going to have less than or equal to negative 2. Just turning it around. Okay, and let's just check that. We've got negative 2 is bigger than or equal to x, so negative 2 is bigger than x, or bigger than or equal to x. So then here you get that x is less than or equal to negative 2, and that makes sense. Okay, now let's have a look at the inequality that Lorcan drew. Lorcan drew that x is bigger than or equal to negative 2. No, the answer is actually x is less than or equal to negative 2. So it should have been x is less than or equal to negative 2. So it should have been a shaded in circle at negative 2, but the arrow should have gone to the left because it's less than or equal to negative 2, not bigger than or equal to negative 2. So let's explain that. And that's how I've just explained that the arrow should point to the left, as the correct answer is x is less than or equal to negative 2, not x is greater than or equal to negative 2. And that's it. Okay, let's look at our next question, question number 27. Okay, so question number 27 says that Annie, Beth and Carly go shopping, and that Annie spends M pounds, so she spends M pounds. Beth spends twice as much as Annie, so she spends double whatever Annie spends. So twice as much would be, well, if Annie spends M pounds, Beth would spend 2M pounds because she spends double it times by 2. And then we're told that Carly spends 5 more pounds than Annie, so whatever Annie spends, Carly spends 5 pounds more. So that would be M plus 5 more. And then we're told that the total amount of money that is spent in pounds is more than £60. And part A says write down in terms of M an inequality to show this information. So Annie spends M, Beth spends 2M, and Carly spends M plus 5, and the total amount of money spent is more than £60. So let's add together the amounts of money spent. So M plus 2M plus M plus 5 would be 4M plus 5. And that's going to be more than £60. So that's our inequality, that 4M plus 5 is going to be greater than £60. And that's it. Okay, and then part B. Part B says each girl spent a whole number of pounds. Work out the least amount that each girl could have spent. Okay, so let's solve our inequality. 4M plus 5 is greater than £60. So let's take away 5 from both sides of the inequality. So if we take away 5 from the left hand side, we'll just be left with 4M, and then that's going to be bigger than, and 60 take away 5 would be £55. Okay, so we've taken away 5 from both sides of the inequality. Now let's divide by 4, so divide by 4 and divide by 4. So if we divide by 4, we're dividing by 4 to get rid of the times by 4, so we'll just be left with M, and that's going to be greater than. And is this a calculator question? Yep, that's great. So 55 divided by 4 is equal to 13.75. So that means the amount of money that Annie spent, M, is going to be greater than £13.75p. But we're told that they spent a whole number of pounds. So that means the lowest amount of money that Annie could spend would be £14. So £14 for Annie. And then Beth spent twice as much. So that would be double that, would be £28. And Carly spent £5 more than Annie. So £5 more than Annie would be £19. So they would be the lowest amount of money that each of the girls could spend. And let's just check that. Yeah. Okay, let's look at our next question, question number 28. So question number 28, we've been asked to solve minus 5x is less than 40. So I've included this question on purpose because whenever you deal with inequalities, and if you multiply and divide an inequality by a negative, you've actually got to turn the inequality sign around. And what I'm going to do is I'm going to show you why that's the case. So if we have minus 5x is less than 40, I'm going to avoid multiplying or dividing this inequality by a negative, and I'm just going to solve it without multiplying or dividing by a negative to begin with. And then what I'll do is I'll show you why then, whenever you multiply or divide by a negative, you have to change the inequality sign around. Okay, so here, if we were solving this without, now normally what I would like to do here is divide both sides of the inequality by minus 5, because this is minus 5 times x, and we don't want it times by minus 5, so we would divide both sides by minus 5. But what I'm going to do to avoid dividing by minus 5 is I'm going to add 5x's to both sides. So I'm going to add 5x to the left hand side and add 5x's to the right hand side. So if we do that, on the left hand side, we're adding 5x to get rid of the minus 5x, we'll be left with 0, and that's going to be less than, and then we'd have 40, and then plus 5x. Okay, now if we wanted to solve this and we want to find out what x is, let's get rid of the 40. So let's take away 40 and take away 40, and we would have 0 take away 40 is minus 40, and that's going to be less than, and then on the right hand side we'd just be left with 5x. Okay, now we want to get rid of this multiplied by 5, so let's divide by 5 and divide by 5. Minus 40 divided by 5 would be minus 8, and that's going to be less than, and 5x divided by 5 would be equal to x. So we've divided both sides of the inequality by 5. So we've now got that minus 8 is less than x. Now if we say that minus 8 is less than x, now normally we put the x first, so let's turn that around. So if minus 8 is less than x, that would mean that x is greater than minus 8. Because remember, whenever we're turning an inequality around or swapping an inequality around, we also need to flip the sign over, because it needs to make sense. Because here we've got the minus 8 is less than x, so x is bigger than minus 8, so then it would read as x is bigger than minus 8. Okay, so the answer is x is bigger than minus 8. Now what I'm going to do is, we now know what the answer is. Let's have a look and see why then, whenever you're dealing with a negative and you're multiplying or dividing an inequality by a negative, you can see that the inequality sign changes around as well. So here we've got the minus 5 times x is less than 40. Now we don't want this times by minus 5, so let's just try dividing both sides by minus 5. So let's divide by minus 5 and divide by minus 5. Now minus 5x divided by minus 5 would just be x, because you're dividing by minus 5 to get rid of the times by minus 5. Or another way to think of it is, remember, a negative divided by a negative is a positive, and 5x divided by 5 is x. And then we've got 40 divided by minus 5, and 40 divided by minus 5 would be minus 8. So we've got x minus 8. And now remember, the answer is x is bigger than minus 8, so the inequality sign has to go around this way here. So it's x is bigger than minus 8. So whenever you multiply or divide an inequality by a negative, you also need to flip the sign around, and that's it. So here, if you divided both sides by minus 5, you'd also have to change the sign around as well. And that's it. Okay, let's look at our next question, question number 29. So question number 29, we've been asked to solve 9x is greater than 5x, subtract 28. So we want to solve this. So if we want to solve this inequality, let's get rid of the lowest number of x's, which is the 5x. So let's take away 5x's and take away 5x's. So on the left hand side, 9x's, take away 5x's would be 4x's, and that's going to be bigger than. And then the right hand side, we're just going to be left with, we're taking away 5x's to get rid of the 5x's, so we're going to be left with minus 28. Okay, now we want to get rid of this 4, so let's divide both sides of the inequality by 4. So let's divide by 4 and divide by 4. So on the left hand side, 4x divided by 4 would just be x. We're dividing by 4 to get rid of the times by 4. And that's going to be bigger than. And don't think that that's going to change, because we're just dividing by 4. So only whenever we're multiplying or dividing by a negative, you need to just swap that sign around. And minus 28 divided by 4 would be minus 7. And that's it. So x is greater than minus 7. Okay, let's look at our next question, question number 30. Okay, so question number 30, we've been asked to solve 4x over 3 subtract 7 is less than 11. Okay, so we want to solve this inequality. So let's get rid of the minus 7 to begin with. So let's add 7 to both sides. So add 7 to the left-hand side and to the right-hand side. Okay, so if we add 7 to the left-hand side of the inequality, we're doing it to get rid of the minus 7. So we're going to be left with 4x over 3. And then that's going to be less than, and 11 plus 7 is 18. Okay, now we want to get rid of this divide by 3. So let's times by 3 and times by 3. So we're timesing by 3 to get rid of the divide by 3. So we're going to be left with 4x, and that's going to be less than, and 18 times 3 would be equal to 54. Okay, we're nearly there. We don't want this times by 4 here, so let's divide by 4 and divide by 4. So on the left hand side, 4x divided by 4 would just be x, and that's going to be less than, and 54 divided by 4, let's half it, that would be 27, and half again would be 13.5, so 13.5. So that means that x is less than 13.5, and that's it. Okay, let's look at our next question, question number 31. Okay, so for question number 31, we were told here's an isosceles triangle and a regular pentagon. So an isosceles triangle, you can see if there's a dash there, so that would be 2x as well. And a regular pentagon, so it's going to be x plus 2, x plus 2, x plus 2, and x plus 2. And the measurements are in centimetres, they're all in centimetres. And then we're told the perimeter of the pentagon is greater than the perimeter of the triangle. And we've been asked to find the possible values of x. Okay, so this pentagon, the perimeter is bigger than the perimeter of the isosceles triangle. So let's actually find expressions for the perimeters of each of them. So let's start off with the pentagon. We've got x plus x plus x plus x plus x, that's 5x. And then 2 plus 2 plus 2 plus 2, that's going to be plus 10. So we've got an expression for the perimeter of the regular pentagon. Now let's look at the isosceles triangle. So 2x plus 2x is 4x, but take away an x would be 3x. And then we've got 15, so plus 15. So that would be 3x plus 15. And let's just check that. 2x plus 2x is 4x. Take away an x would be 3x. And then we've got our 15. So we've got expressions for the perimeter of the isosceles triangle and then expression for the perimeter of the regular pentagon. And we're told the perimeter of the pentagon is greater than the perimeter of the triangle. So 5x plus 10 is greater than 3x plus 15. And we've been asked to find possible values of x. So let's solve this inequality. So let's get rid of the lowest number of x's. So that's going to be 3x's. So let's take away 3x's and take away 3x's. Okay, so on the left hand side, 5x's, take away 3x's is 2x's, and then plus 10. And that's going to be greater than, and we're taking away 3x's to get rid of the 3x's, so we're going to be left with 15. So we've now got that 2x plus 10 is greater than 15. So let's take away 10 and take away 10. So that would leave us on the left hand side 2x, and that's going to be greater than, and 15 take away 10 is 5. And now we're almost there. Let's divide by 2. So if we divide by 2, we're going to get that x is greater than 2.5. So the possible values of x would be any value that is greater than 2.5 centimeters. And that's it. Okay, let's look at our next question, question number 32. Okay, so question number 32, we've been asked to solve 8 is less than 10, subtract x over 2. Okay, so we want to solve this inequality. So what I'm going to do is because we're taking away x over 2, I'm going to add x over 2 to both sides. So I'm going to add x over 2 to the left-hand side and add x over 2 to the right-hand side. So on the left-hand side, we had 8, and then we're adding x over 2. And on the right, and that's going to be less than. And on the right-hand side, we're adding x over 2 to get rid of the minus x over 2, so we'll just be left with 10. Okay, so that's fantastic. Now let's get rid of the 8. So let's take away 8 and take away 8. So on the left-hand side, we'll be left with x over 2, and that's going to be less than. And 10 take away 8 is 2. So we've now got the x divided by 2 is less than 2. Now we don't want this divided by 2, so let's times by 2 and times by 2. And then if we do that on the left-hand side, we're timesing by 2 to get rid of the divide by 2. So we're left with x, and it's going to be less than, and 2 times 2 is 4. So that means that x is less than 4. And that's it, we've solved that inequality. Okay, let's look at our next question, question number 33. Okay, so question number 33, we've been asked to write down the largest integer that satisfies 10 subtract 4x over 7 is greater than 5. So let's solve the inequality to begin with. So let's get rid of this big divide by 7. So let's times by 7 and times by 7. So on the left hand side, we're timesing by 7 to get rid of the divide by 7. So we're going to be left with 10 subtract 4x. And then that's greater than. And then on the right hand side, we've got 5 times 7, that's 35. Okay, fantastic. Okay, that's fantastic. Okay, now we want to solve this. I'm going to add 4x's to both sides. So add 4x's and add 4x's. On the left hand side, we're adding 4x to get rid of the minus 4x. So we're going to be left with a 10. And that's greater than. And then we're going to have 35 plus 4x. Okay, now we don't want this 35. So let's take away 35 and take away 35. 10 take away 35 is minus 25. And that's going to be greater than. And then we're going to be left with 4x. So we're getting there. I'm actually going to turn the inequality around at this point here. So rather than saying that minus 25 is greater than 4x, we can say that 4x is less than minus 25. And then now we just need to divide by 4 and divide by 4. And if we do that, we get on the left-hand side, x, and that's going to be less than. And then on my calculator, I'm just going to do minus 25 divided by 4 is equal to minus 6.25. So x is less than minus 6.25. Now the question, if we go back up here, I'm just going to write that x is less than minus 6.25. So if we go back up to the question, we're asked what's the largest integer? So the largest integer that satisfies this. So we know that x is anything that's less than minus 6.25, so minus 20, minus a million, minus a billion. But the largest integer that would work here would be minus 7, because minus 7 is the biggest value that this value of x could have. It couldn't be minus 6, because minus 6 isn't less than minus 6.25. So the biggest value, the largest integer that x can be, would be minus 7. So let's write that down, minus 7. Okay, let's look at our next question, question number 34. Okay, so question number 34 says, given that y is bigger than or equal to 2, but less than or equal to 8, and z is bigger than or equal to 7, but less than or equal to 12, we've been asked to find y plus z. Okay, so we want to find y plus z, the inequality for y plus z. Okay, so let's consider the smallest possible value for y plus z. So y plus z, the smallest possible value could be, well, y is bigger than or equal to 2. So the smallest possible value that y could be would be 2. And z, the smallest possible value that z could be would be 7, because z is bigger than or equal to 7. So the smallest possible value for y plus z would be, well, 2 plus 7 would be 9. Because the smallest value y could be is 2, the smallest value that z could be is 7, adding them together would be 9. So that's the smallest possible value for y plus z. So it means that y plus z must be bigger than or equal to 9. Okay, so now let's consider the biggest possible value of y plus z. So the biggest value that y could be would be 8. The biggest value that z could be would be 12. Well, if we add them together, 8 plus 12 is equal to 20. So that means the biggest value that y plus z can take is 20. So that means that y plus z must be less than or equal to 20. So that means that y plus z must be bigger than or equal to 9, but less than or equal to 20. And that's it. So let's write that down. That y plus z must be bigger than or equal to 9, but less than or equal to 20. And that's it. Okay, let's look at our next question, question number 35. So question number 35 says x and y are integers. So they're integers, and that's quite important in this question, and we'll come back to that in a minute. We're told that x is bigger than or equal to 15. So it could be 15, could be 27, could be a million. We're then told that y is bigger than 18. So remember, it's an integer, so that means that it could be 19, 52, 100, a million. We're then asked to work out the smallest possible value of 3x plus y. Okay, so we want to find the smallest possible value of 3x plus y. Let's find the smallest possible value for x, the smallest possible value for y, and then substitute them in. So remember they're integers. So the smallest possible value of x would be 15. That's the smallest possible value of x. And the smallest possible value of y would be 19, because remember it's an integer and it's bigger than 18, so that would be 19. So if we substitute in x is equal to 15, so x is equal to 15, and y is equal to 19 into this expression, we can find the smallest possible value of it. So if x is equal to 15, 3x would be 3 times 15, that's equal to 45. So 45, and then plus y, that's 19, and 45 plus 19 would be 64. So the smallest possible value of 3x plus y would be 64, and that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on inequalities. I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. If you need any extra help on inequalities, such as drawing them on number lines or solving inequalities, if you look at the videos on Corbettmaths, the video tutorials on Corbettmaths, videos 176, 177, 178 and 179, they'll be absolutely fantastic for you. Alternatively, you can scan this QR code. But I really hope you found this video useful, and if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.